All right, so hi everyone, thanks for having me. So my name is Sirard. I'm Associate Professor in Kinesiology. So my task, I guess, for today was to tell you about what kinesiology is and what we do and that sort of thing. So I'm going to start off with the what and why, and then we'll do maybe a little introduction sort of stuff, and then we'll continue on with the who and the how. So first of all, so what is kinesiology? And so it's basically the study of movement, or the study of human movement. And so that's a really broad topic. So we cover a lot of ground, from molecular physiology all the way up to population behavior and population health. So when we say we're a multifaceted field of study, that's very true, but the intellectual focus is always around physical activity, is what we're sort of interested in. So pulling, and so this quote is just from the National Academy of Kinesiology. So we call ourselves kinesiology here. So I'm actually a double alumnus of UMass. Did my undergrad in marketing. Turns out I'm really bad at selling things. And so switched gears, came back to school for something I actually enjoyed, which was exercise science at the time. And we've since changed our name. There are other departments that still use exercise science, I think, have more of a sort of a performance sort of angle. We have more of a health sort of focus through the research that we do and the curriculum that we teach. And then so sometimes kinesiology departments are within sort of a kinesiology and rehabilitation sciences, or kinesiology and health sciences, or in a college of health sciences with nutrition and other health science folks. So where we sit here is in the School of Public Health, which works for folks like me and Amanda, who are more on the physical activity epidemiology side of things. For the folks who, in our department, that studies sort of the molecular physiology piece, it's a little bit more of a stretch for them. But so because we do sort of span sort of this broad range. So everything we do is sort of related to physical activity. So I wanted to make sure we define what physical activity is, so we're all on the same page there. So physical activity I see as this umbrella term that again covers a lot of ground. So any movement produced by skeletal muscle that results in energy expenditure. So we have the behavior, the body getting involved there, the muscle, and the end result is a physiological process, or the energy expenditure. So in sort of my world and sort of the epidemiological world, we think about physical activity in these different domains. So it could be leisure, work, transportation, or home and caregiving domains. And then when we try to quantify how much physical activity someone's doing, we want to look at sort of this fit principle. So frequency, intensity, time or duration, and then also type. So because physical activity is so broad, I'm doing physical activity right now. I'm standing and I'm waving my arms around while I'm talking. But also, you could do like household, sweeping floors, working in the garden. If you're, walking to or from work, that's, transportation. If you're, a librarian and you have to go to a classroom to do an instructional session, you're walking across campus, that's walk for transportation, that could be in the transportation domain, or might be in the work domain. So it depends. So they're not necessarily mutually exclusive. I put reshelving books there because I was talking to librarians. Probably pretty old school. And then, for the leisure time, you might be out riding your bike with your kids or by yourself. And then I have exercise sort of underlined and bolded there, because exercise, I think, oftentimes gets confused with what we do. But exercise is just one type of physical activity. So it's one specific form of physical activity that fits under that umbrella. And it's usually repetitive. You're usually doing it to improve some aspect of fitness. And so I just wanted to make sure that distinction was clear. So we're talking about when we talk about physical activity, it's sort of a broader term, but exercise is a more specific one. Fitness has multiple components to it. I won't really talk about much of these, but I thought I'd just run through them really quick. So aerobic capacity, or your maximal aerobic capacity. So that would be things like if you've had to do, or someone you know has had to do a stress test, a cardiac stress test on the treadmill. They start you off at a comfortable walking pace, and then it gets faster or steeper until you can't go anymore. That's sort of the clinical sort of maximal aerobic capacity test. But you also might remember the torturous beat test from your school days, or the mile run test in PE. So both of those are sort of field assessments of maximal aerobic capacity. And then we've got muscular strength. So the maximum weight that you can lift once is what we're talking about with strength. So your 1 repetition max, or 1 rep max. So that's sort of, and also, like, this is not just for the bodybuilder guys in the gym, right? This is for everybody. And we'll talk about, I don't know if you're talking about recommendations.
A little bit, yeah.
A little bit, so.
Yeah.
But strength training is actually one of our physical activity recommendations for the population. And then muscular endurance is similar, where you're not trying to move a weight just once, that maximum 1 rep. So the maximum number of repetitions you can do using a submaximal weight. So again, going back to your PE trauma, so pull-ups or sit-up test, right? Sorry, I don't need to bash on the PE folks, but I realize that some of us have not good memories from that. And then flexibility and mobility is, what it said. So the sit and reach test was one of those tests you did in PE class. And then there's like the upper body, the touch the fingers behind the back one, which it seems impossible. And then body composition is our 5th one there. So the easy way to measure this, and not so great way to measure it, is through body mass index, so height for weight. And that's sort of a blunt sort of instrument. It's easy to do in a large number of people, or you can get self-report, so that's why people use it. A better measure would be something like a DEXA scan, or some other measurement where you're looking at the actual body composition, so percent body fat, or the amount of fat that you're carrying around your central adiposity, that sort of visceral fat, which we know is related to more negative health outcomes. So those are 5 areas of fitness that we sort of look at. Again, in our department and some others, we tend to be more of a focus on health rather than fitness, but they are both related to each other and related to health outcomes. So related to those health outcomes, we do have physical activity recommendations. So these physical activity guidelines for Americans, we're in our 2nd edition. The first came out in 2008. So this is a big, long document, but it sort of lays out the scientific evidence for support for physical activity and in relation to these health diseases. So we can relate, like, physical activity is good for everything. Let me just say that up front. It works for everything. But so pick a disease, any disease.
Diabetes.
Diabetes, oh my gosh, perfect. So type 2 diabetes, right? So with type 2 diabetes, you're insulin resistant, right? And so your muscles and other cells in your body are having trouble getting the blood sugar out of the blood and into your tissues, right? A huge consumer of that blood sugar are your muscles. And so if the insulin receptor on the muscle cell isn't working, the insulin doesn't bind and the blood sugar can't get into the muscle cells. So what exercise does is it maintains those insulin receptors and even upregulates them so that you're better at getting that blood sugar out of your system. Exercise, just muscle contraction by itself, has a separate mechanism to get blood sugar out of the bloodstream as well. That doesn't rely on insulin. So you get sort of a double bang for your buck there. So one other chronic disease. Pick the chronic.
Heart disease.
Yeah, so another classic related to type 2 diabetes. So heart disease, right? So basically, especially with aerobic exercise training, you're working your heart. Your heart is a muscle. So you're working that heart, you're working the lungs and the musculature around the lungs. And so both of those combined are going to help reduce the amount of plaque formation in your arteries. And then sort of help prevent cardiovascular disease, right? So,
what about something like schizophrenia?
Yeah, so mental health, I don't know that we have a nice body of evidence for schizophrenia, but we do have evidence of depression. So we have good evidence that physical activity can help reduce or prevent depression, mild or to moderate forms of depression, not sort of severe sort of mental health diseases.
What about asthma? That seems problematic.
Yeah. Oh, asthma. Yeah.
I was almost going to say that one. So.
Yeah, and I think there are different kinds of asthma. There are different triggers for asthma, and so it might have more to do with the environment that you're working in. And so I know that some swimmers can be prone to asthma because they're in a hot, humid environment, and then they might go out to a cold, dry environment, and that can sort of trigger some stuff. But I know we do have, really high pediatric asthma rates in Springfield down the road here. And I've been thinking about that a little bit and how we want kids to go outside and play, but maybe they shouldn't go outside and play if the air quality is not so good, right? Yeah, I don't know that much about asthma. Good question. Oh, you stumped me. Good one. There you go. Okay, so we have, and then, helping prevent 8 forms of cancer now, dementia, Alzheimer's disease, sort of all-cause mortality, so preventing dying from anything. So that's a huge one. I think we're going to talk a little bit more about that. So basically adding life to your years, or adding years to your life. But we also have down here improving physical function and quality of life, so adding life to the years that you have. So it's quantity and quality, so we're getting both sides of that from our physical activity. And then for older adults specifically, reducing the risk of falls, and if you do fall, reducing the amount of injury that you sustain from those falls. So breaking a hip as an older adult is not a good thing and sort of leads to a downward spiral. So if we can prevent that or prevent it from being as severe, that's a great thing. Reducing postpartum depression, reducing risk of excess weight gain, helping people maintain a healthy weight. And if you do have some of these conditions, sort of, keeping those in check. And then for youth, so I do a lot of research in schools, school-age children, adolescents, so improving cognition. Working with schools and trying to get into schools to do research is challenging these days, but if we can say, physical activity will help your kids think better, that sort of gets us in the door sometimes. And again, sort of, improving fitness and heart health even, bone health, and reducing risk of depression. So all sort of great things. Again, like physical activity is great. It's great for everything, right? Okay, so now I thought we'd do a few introductions. So maybe not everybody, but so I was wondering, some of you other brave people can shout out. So name an institution, which department or colleges you work with, and then have you had any interactions with kinesiology folks, and good, the bad, the whatever? Yeah.
So off the bat, not really, but I'll say my name is Bianca, and I come from Abbott Public Library, which is on the North Shore, part of the Noble Library Network. It's a public library. I'm the teen librarian there, and in Marblehead, sports are like very huge for youth. So there are tons of student athletes all around, but they're not really the teens that end up coming and hanging out with me because they're doing like their sports things.
Yeah.
So
Yeah.
I would love to have more active people come by, but I don't know when that might be. So public teen librarian is like very different than an academic librarian or sort of a researcher like who you are.
Yeah. And so some sort of like, getting those team members some sort of literature, some, that could help them.
I'm here to learn.
Develop their, cool. All right, anybody else?
Actually, I'm currently working with, so Colby is a D3 institution, but we have a really, really robust athletic department. It's huge. And so I'm currently working with a bunch of the trainers. I don't know if she has a PhD in kinesiology, but what we're doing is creating a database basically on different responses that athletes are having. And it starts with like jumping on that little scale thingy to like measure your, because they're interested in tracking injury, right? And performance. And in a D3 school, which is different than a D1, coaches can't have information off campus, so it's an exercise in both privacy, and season. It's an exercise in privacy, but also in different metrics that they want to collect around performance. So, like if you're having to do, they do something on a plate where you go down and you jump up on the plate, and they measure like how high, and it does other things as well.
Okay.
Yeah.
It almost sounds like a force platform.
Yeah, I think that's exactly it. Okay. Because I'm like, dudes, I work at home where nobody can see me. So I'm like, and I'm certainly not going to jump on a plate in front of you. So.
Yeah. But, and so we do have sort of here the hockey team, and I think maybe one of the other sports teams, they wear these biometric shirts.
Yeah.
And so we're getting all sorts of data from them, and we're trying to work out some internship stuff to, get access to that data and how we use that data and mindfully.
And I took it on only because I'm super interested in, from my time in industry, just about privacy, especially around biometric data. So I wanted to basically like, hey, let's actually try to do this and see if we can really make it non-invasive.
Right. Yeah.
So.
One more.
Sure, I'll be great.
Yeah.
Hi, I'm Leia. I am from the UMass Chan Medical School. So we do not have a kinesiology department or anything at the medical school. But oddly enough, my supervisor in our scholarly communications department happens to have a degree in kinesiology as well as a degree in divinity and a library degree. Sally did a lot of school, just for fun. So she has always been really interested in sort of that exercise science, public health aspect of it.
Yeah, so our at the medical school, we have faculty here in our biomechanics group who has sort of a satellite lab out at the Worcester Medical School. And so they can, she's interested in osteoarthritis folks and how they move compared to how, non-arthritic people move, and coming up with new intervention strategies. So there are some, some of those connections as well. Because we don't have a medical school right on campus, we tend to not have too much of that clinical focus. So let's talk about what the who of kinesiology, I guess. And let me just, not being rude, I'm just checking the time. So going over sort of the subdisciplines within kinesiology. And again, we do span quite a range, an intellectual range. And so I thought, so we cover, I think, the basics. So motor control and movement neuroscience are sort of the brain-body folks. So we'll start there. And then the biomechanics folks are sort of how the body moves in space. Physiology folks are looking at sort of what's going on inside the body during and after exercise. And then folks like me, the physical activity and health crowd, are looking more at things from a behavioral and contextual sort of space. And then here on campus, we don't have a research focus in health and fitness, but our non-tenure track faculty, our lecturers, do a number of elective classes that look at sort of, or help foster like folks that are interested in personal training and sort of that sort of route. So we'll talk a little bit about that. Things we don't really do here are the clinical side of things. Again, we don't have but I'll sort of touch on those, and then the PE pedagogy piece as well. We sort of have our roots in there, but we, I think, sort of split for the most part. Okay. So starting with motor control and movement neuroscience, so understanding the control and coordination of human movement using dynamical systems theory. I don't really know what dynamical systems theory is. Please don't ask me. This is not my area. But so the idea is, so our bodies are very complex. The brain is very complex. And so me just reaching for my phone, I don't have to really think about doing that. I'm not consciously thinking about left foot, right foot, left foot, right foot, right? It just happens. And so how our brain works with our body to communicate and take in the external input that we're receiving from our sensory apparatus and sort of telling us like what we should be doing, and sort of bypassing the brain for a lot of that, just using the spinal cord and sort of muscle memory, if you will, to do a lot of those movements. So this is in kinesiology for performance purposes. So if you're thinking about someone trying to swing a bat or a golf club, you might be interested in sort of this motor control piece, or a child learning how to skip. So if you ever watched a preschool kid try to learn how to skip, it's hilarious. But in our department, we, like the folks that we have working in this space, are looking at folks, stroke patients who have some sort of paralysis and are working through and learning how to move their limbs again. And so knowing how that works in a healthy condition, we can sort of look at, where did we need to go? What do we need to do with this person to get them back to, just moving their arm again and grabbing a cup. So multiple sclerosis, Parkinson's, we have folks looking at, post-concussion syndrome. And so the whole idea is, sort of this cognitive or brain control of gait, posture, but also upper limbs and grasping movements, and so how we're controlling our body in space. So that's, and then, we all use some fancy math, I think, to analyze our data. They use sort of other fancy math that I don't know. This sort of mathematical modeling that they do to understand and analyze their data. Okay. So once the brain tells our body what to do, and we can see the body moving in space, so the biomechanics folks are looking at how the muscles, bones, and tendons and ligaments all work together to produce movement. So I don't know if anybody here a golfer?
No, but I'm in physical therapy.
Wow. Okay, yeah. So
And my walking gait, I just had knee surgery, so we're looking at my walking gait.
Yeah. So it's one of our former PhD students, but he's in one of our biomechanics labs. And so he has all these markers on him, and he's in a space where we have these cameras, so 6 to 8 cameras all around you, so you can get a 3D image of the person and connect the sensor dots, right? So then you end up with, let's see if this works, I don't know, the AV. Oh, hold on. Okay, so someone with, and here are your, oh geez, at the bottom here. Our force plates are on the bottom here. And so we're looking at the arrows are giving us the magnitude of the force that's being applied through the foot, and then the direction of that force being applied. And this person would have had markers all over them, and then they made it into a skeleton because it looks cooler than a figure. But yeah, so you can see how the forces change, where the person's standing. So, starting off with most of the weight on the back foot and then moving into the forward foot. And you can get, the three-dimensional picture of that. And then we go to this one. Oh, I have to put up with two ads. I can't skip. Okay, so here's sort of a data collection setup in the biomechanics lab. So this person has all these markers all over his body. He's in this grid space and with cameras all around. And on the computer here is sort of a live feed, again, connecting all of those sensors to create the little stick figure image. We're just going to do a couple seconds of this. So he's waving, and it's very fun. We snap from the internet. And then, so this is cool. So we got all the markers connected, and you can see him walking in both. And so what the biomechanics folks will do is use their fancy math to get at all of the forces and the torques and all of their sort of mathematical procedures that they do to look at sort of how someone normally walks, and maybe how someone walks with sort of a clinical condition or some other disease state. So I mentioned Kath Boyer in our musculoskeletal and orthopedic biomechanics lab group. So she's the one that has the satellite lab out at the medical school. But she's interested in sort of joint pathology and how that changes people's movement. And then if we understand that process, can we come up with better intervention strategies for those folks, sort of before and or after a knee replacement surgery. Okay. And our biomechanics folks do other things as well, but that's sort of their bread and butter is this sort of kinematic analysis sort of stuff. Okay, and then moving on to sort of what's going on inside the body. So the physiology folks are looking at the physiological responses to exercise, so compared to a resting state, and the body's adaptation to chronic exercise, so when you do some exercise training over time. So we could look at, you guys are sitting right now, what would happen if you were to get up and run to the campus center, and what's going to go on inside your body to allow you to do that exercise, right? And then if you were to do sort of a couch to 5K sort of thing, right? So you're starting off, your baseline is the couch, and then you get, 6-8 weeks of training in, and where is your body now compared to where it was 8 weeks ago? And so oftentimes our physiology folks are looking at sort of the heart, lungs, and muscles, and sort of folks may specialize in one or the other, but you sort of need to know what's going on with all of them to really get a sense of what's happening. And I didn't put this here, but sort of endocrinology would be a part of this, so how your hormones are changing based on your exercise or exercise training. Okay, so all of those things are interactive inside the body. So that's sort of a systems level approach. We can go down a level, and if we look at, you guys can't really see this level. Yeah, but so this is sort of a schematic of a muscle fiber, and then if we go down sort of the muscle fiber level is our muscle cell. So we have folks that look at things at the cellular level and sort of the mechanical and physiological properties of a single muscle fiber. So they'll go in and do a muscle biopsy usually of the thigh, and they'll just go in and yank some muscle tissue out. It's okay, it tastes like chicken. So they can do look at sort of physiological properties, but also mechanical properties of that muscle tissue, and sort of cellular signaling pathways, and sort of looking at type 2 diabetes and those processes, so things like that. And then this is kind of rare, but here at UMass we do have one of our professors gets down to the molecular level and looks at how these individual proteins within the muscle fiber are actually connecting and working together to contract. So I should have put this in an animation, but we have these proteins and they sort of grab on, the myosin grabs onto the actin and pulls it, and pulls it, and pulls it. And so that's your muscle contracting. That's sort of how it works. But they're exploring that in more detail and trying to figure out maybe novel pharmaceutical therapies for heart failure, those sorts of things. So, and sort of preventing fatigue. Okay, so that's sort of going on inside the body, and then if we pull out a little bit and look at sort of what's happening outside the body in sort of a behavioral and contextual way. So I came up with this. I don't know if this is a great definition for this area of research, but so understanding the multi-level factors that influence physical activity, developing behavioral interventions to support theory-based, sustainable behavior changes that positively impact those health outcomes, and assessing being able to measure or assess those behaviors of interest accurately. So, what are the facilitators and barriers to physical activity? Let's develop interventions around those. And then if we do the intervention, can we measure the effect accurately and reliably? And then, understanding this dose-response relationship between physical activity and health outcome X. So how much activity do we need to do to prevent heart disease? How much, and Amanda's going to talk some about that. I won't. But since this is where I sort of sit in sort of my research space, so I thought I'd do a little more introduction of me and what I'm interested in really quickly. So I am interested in developing these community and school-based interventions that work to increase activity, decrease screen time, improve diet quality or dietary intake, preventing excess weight gain in children and adolescents. So we've done a couple smaller studies here. I've been involved in other large NIH-funded studies that have done interventions. They're really hard to pull off and really hard to see substantial effects. But that's the goal. In order to do that, we need to understand what the determinants of the behavior are. So what are the things that are going to, what are the facilitators and barriers? So one of our NIH-funded studies is this food activity screens in teens. So there we're looking at middle school students, their personal networks in school, and how their networks influence those behaviors. So who you know, who you like, and who you don't like, that sort of thing. So stupid COVID screwed up our data collection, but we have some good data and we're working on that now. And then if we understand sort of these multi-level factors, that's another issue, but if we understand what buttons and levers we want to push with our intervention, we need to be able to measure the outcome variable. If our goal is to increase physical activity, do we have a good way of assessing that? Traditionally, we would use a questionnaire sort of approach, paper and pencil back in the day, and now we've mostly moved to online surveys. But that can work for adult populations, but when you get to kids under the age of 10, they really start to lose grasp on the concepts that we're trying to get at. I tried doing a survey in first graders, and I was asking them what like what they ate yesterday. And, yeah. So this one little girl, is that like tomorrow? No, it's yesterday. Yeah, so they really didn't work out. So for the physical activity side of things, we tend to use these wearable devices, accelerometers. So sort of like the research version of a Fitbit or an Apple Watch. And so we get some numbers from those devices, and then we have to make sense of those numbers. So we had another NIH study looking at how we can do that better in children and adolescents. So we use some machine learning algorithms to help us do that. So that's sort of my sort of fancy math that we use, or regression analysis. So that's me a little bit. But the idea is, we're hopefully going to get strong, healthy, confident children that grow up to be strong, healthy, confident adolescents, and that translates into adulthood. So we'll see. I haven't figured it out yet. But sort of thinking about those multi-level factors, and so we often rely on the social ecological model. And I think what this does is it helps us realize that it's not just personal motivation why someone's active or not active, right? There's a lot of other stuff going on. So we've got sort of the behavior of interest at the center, these individual level determinants. So a lot of that has to do with your cognitive beliefs or attitudes, might be your, what we label self-efficacy. So your confidence in your ability to do activity is a big one. Social support that you have, and then so that sort of builds us out to the social environment. But things there may or may not be under your control, especially if you're a kid. Right, the social cohesion in your neighborhood or your culture. We were working with some Somali immigrant populations when I was at the University of Minnesota, and for girls, riding a bike was just not something girls would do. So just interesting how different cultures have different ideas or beliefs around physical activity. And then getting sort of bigger and bigger, so the built environment, how urban design or land use patterns may influence your decision to be active or whether or not you can be active, right? Are there sidewalks? Is it safe? Maybe there are sidewalks, but maybe they don't go anywhere. Maybe it's just a residential neighborhood and there's, you can't walk to the store or anything like that. And then the natural environment, so air quality, we just had the smog, the smoke from the wildfires, and not too bad here. I don't know if anybody else was like really bad, but yeah. So obviously that's an issue, and then just weather. Again, I lived for several years in Minneapolis, and beautiful for like 5 months of the year, just like so cold. So that obviously affects what you're going to be able to do. So just recognizing that we know that our behavior is influenced and sort of at this individual level. So you're taking all this other stuff in from these higher levels and sort of filtering that through your brain, right? And that is then going to produce the behavior, whether that be going to the gym or watching Netflix. So recognizing that there's a lot going on there, it's a complex problem. So to get at that, we have adopted a number of health behavior theories from psychology. My whole reason for showing this was to sort of impress upon you guys the broad scope of what we're dealing with, right? So if I'm interested in this intervention, so we might be looking at gender differences, so maybe I need to pull in someone from gender studies. If we're talking about cognitive beliefs, maybe someone from psychology, anthropology, geography, and geographic information systems is a big player in this space. Transportation folks. So I think in our domain, maybe more than the others, we do tend to collaborate across these different disciplines quite a bit. So just so a few of the prominent theories that we use, health belief model. I have this one in parentheses because I don't think it really works. It sort of relies on it assumes that people are going to make a rational choice, and which I think is a big downfall right there. So folks don't use that one so much anymore. One of the two big ones that I see these days are social cognitive theory, that links sort of the individual, the behavior, and the environment, and they all sort of interact together to produce your behavior of interest. And then there's a number of motivational theories. The one that we see a lot in the physical activity space is the self-determination theory, which is trying to get people from an external motivator to an internal motivated state. So we don't necessarily, so if you're going to exercise because your doctor said you had to, fine, okay, we'll take that. But can we move it a step further? And we want you to get to the point where, okay, maybe I'm exercising because I want to look good in my bathing suit because it's summer. Well, that's okay, but it's still an external form of motivation. Now, well, maybe I'm exercising because I want to prevent that heart disease or that type 2 diabetes that's going to happen to me in 20 years. That's better, but what we want to get to is I'm doing the physical activity, I'm doing the exercise because I like doing it when I'm doing it. It's enjoyable in the moment. So you're doing it because it feels good. And so I know that's a stretch for a lot of people, but but that's where we want to get to. And if you're crazy like me or Amanda, you can get there. Okay, so and then looking at dose-response relationships, I'm not going to spend too much time on this, but it does sort of depend on the health outcome we're looking at. And so getting back to our physical activity recommendations, some of just the basic ones. The minimum would be 150 minutes of moderate intensity aerobic activity per week. So that's 30 minutes, 5 days a week, basically, of brisk walking. And also at least 2 days of muscle strengthening activity, right? So that, again, is good for not just the muscle head guys in the gym, right? It's for everybody to help prevent those falls as we get older and, again, add that quality of life as well. So for school-age kids, we're looking for 60 minutes of moderate to vigorous physical activity per day, and some muscle strengthening activity that they don't quite specify. And then for preschool-age kids, we want to see at least 3 hours per day of just non-sedentary time. So light, moderate, vigorous, so just not sitting. But 3 hours of that sort of spread throughout the day. Okay. So I think we're just going to touch on those. That's just sort of really quick. Those are the basic ones. Okay, so that gets us through some of the who. So then moving on, so the other who players, so this clinical side, again, we don't necessarily have this here because we don't have the medical school, but a lot of programs will have more of a clinical exercise physiology focus. So that can be cardiac rehab or pulmonary rehab sorts of training or those sort of internships in those settings, and really working with understanding, chronic disease populations that might have a number of medications that they're taking, and, how are we going to fit physical activity or exercise training into that without doing more harm than good, right? A lot of our students, so we don't have a physical therapy major here or a doctoral physical therapy program, but a lot of our students, I would say 90% of our students as freshmen come in saying they want to do physical therapy. Most of them, well, maybe not, a lot of them don't actually do that, but that is sort of a goal for a lot of them. I've had a number of folks go on to physical therapy, but also medical school, nursing is a big one, occupational therapy, dentistry. So there's sort of a lot of allied health fields there. I put special education and adapted physical education here just because of the clinical nature of some of that work that you might need to do. And then athletic training is another big one. Again, we have some connection with the athletic teams here, and we're trying to grow that for our undergraduate student population. So that's working with sport teams on sort of injury prevention and helping with treatment management. So if someone's working with a sports medicine physician, making sure their ankle is wrapped properly, or that sort of thing, to help prevent injury, basically. Okay, so that's I think all I was going to say about clinical, and then physical education, pedagogy. Again, we don't have that here, so some kinesiology departments will have that as part of, or faculty that do this as part of their curriculum. And so I was also at the University of Virginia before I came here. And so they had a couple faculty on staff that were specialized in adaptive PE for those kids with special needs. And so I think kinesiology sort of has its roots in PE, physical education. I think that's sort of where we started. But I think as opposed to having more of a pedagogy and like trying to teach people how to move, we sort of like, there are those folks, and then there are those other folks that want to just understand, like the biomechanics folks want to understand how the bones move, or how the brain works with the bones, right? So just different sort of foci there. Okay, and then sort of the health and fitness area. Again, we don't have a research program, or none of the tenure track faculty have research in this area necessarily. But our undergraduate curriculum does have courses in it that allow people to explore this sort of stuff. So we have the UMass Body Shop, which is run by one of our faculty, one of our lecturer faculty, and she incorporates that as one of their classes on sort of fitness, wellness center management. And so for their lab, for the class, the kids work in the fitness center, working behind a desk, taking care of the equipment. Some of them do some personal training. So they get some experience that way. So again, so this area, we're looking at sort of the personal trainer folks, and that can include obviously in person, but now online, the whole explosion of online personal trainer folks and the whole Peloton craze and those folks. So there's a lot of that going on in that space, but also strength and conditioning specialist is someone who's going to more specialize in strength and power development in athletes. But we see those folks in high schools. Some high schools are well enough off to have that, and then also at the college and the professional level, obviously. And then I wanted to throw in a few other folks here. So community activists, and I guess too, under the personal trainer and community, maybe put those sort of the corporate wellness folks as well. But these community activists that might be working with people and organizations out in the wild in the community. So one, like Walk Boston is one, People for Bikes, getting more people on bikes, and then I Love Girls on the Run. So that's sort of all over the country now. And then our behavioral intervention specialists. So these might be undergraduate or master's level folks who help us deliver our research-based intervention. So if I'm doing a school-based intervention or worksite intervention, and I can't go out and do all those visits or counseling with all these people. So we have these people go out, train them, make sure they know what they're doing, obviously, but then they go out and actually deliver the intervention and have that face-to-face interaction with people. Sort of a take on that, sort of a cultural tailoring approach would be to use these promotoras, which are in the Hispanic or Latin community. So typically women from those communities that are sort of trusted and seen as community leaders. They're the people that you go to ask questions about. But we sort of train them to help deliver our interventions so that it's coming from someone that people in the community trust. And so to hopefully we get more buy-in that way. So, and we do that sort of thing at the, within a school. We might try to find a champion at the school who's going to work with us and help us deliver our interventions. But okay, so I think that sort of wrapping up the who part of the talk then is kinesiology is the center of the universe. And so at least the campus universe. So kinesiology are different sort of areas in that center bubble, and I could have drawn arrows between all of those different because we work together on so many different things. But then all of these different departments across the university that we sort of tie in one way or another. And that might be different on different campuses, different institutions. So we do sort of go from like the basic STEM disciplines and, for my one of my projects, I collaborate with folks in sociology and statistics and nutrition and that sort of thing. Okay. I have a couple minutes. Okay. So how do we work with librarians? I think oftentimes, especially our students they just want to do it, right? But they don't know what they're doing. And so trying to put the brakes on and like, let's talk to Ellen and figure out how we should do this in a more appropriate way. So that's been my experience, I think, primarily, and maybe mostly with the kin faculty, is, working, and Ellen is our librarian for kinesiology, so we deal with her. But helping us out with systematic reviews, understanding, so what are the databases we need to be searching, primarily PubMed, maybe Sport Discus, but also if we're trying to tap into psychology and sociology literature, we might be, going outside those sort of traditional health or medical databases. What are those keywords? And then also, helping us think about what, we need to document this stuff, and so we don't end up doing the same search over and over again and, losing ourselves. So that's been a huge help for me, my students, and I know others in the department as well. And then Ellen's been kind enough to come and do some classroom presentations for me and some other faculty in kinesiology. So just basic things of how to access the library and the library website, how to navigate that. How do you conduct a literature review, sort of synopsis of that, and then trying to get them to use some citation software. But yeah, so going through some of the basics of like what you can do there and how easy it'll make your life on the back end. And then, making sure they know that interlibrary loan is a thing, which is amazing. And so there's no excuses why you couldn't actually get the full article and you just read the abstract. That doesn't count. So all of that, I think, is sort of the primary ways that I've sort of interacted with the library. And then, so there's probably like other things, like, so the library here does poster printing, which is great for our students. They have a poster presentation at a conference. But also there's these recording studios, multimedia workstations. So I know some of our faculty are starting to move away from just exams and quizzes for assessments. And, can you create a podcast on this topic, and maybe using those resources would be good instead of just them using their laptops or whatever. So those sort of resources, and there's probably a lot of stuff I don't know, but probably should. So, wrapping up, so go UMass Kinesiology Libraries. And yeah, that's it. We'll take any questions.
So we have time for a few questions, but John will be joining us for Amanda's session as well, and we'll have a longer question and answer with both of them after we have all the information. But yeah, we've got time for 2-3 questions if you've got a burning one right now.
I noticed that you connected kinesiology to economics, and I was wondering if you could just, a couple of slides ago, I was wondering if you could just talk briefly about that.
Yeah, so so there's a couple ways that we look at that. So Amanda might be able to describe this better, but looking at sort of the cost of inactivity on sort of healthcare costs, which is in the billions of dollars. But also when we do a school worksite community intervention, a lot of times we'll throw in an economic assessment there to see like how expensive that was to deliver that intervention and what we got from that for outcomes, and sort of was it cost effective to do that intervention versus doing nothing and waiting for someone to have a heart attack or something.
Thank you.
So, yeah.
You linked kind of the built environment and the social environment to whether a person can engage in these behaviors. Do you ever link into environmental justice research when you're looking at a person's environment and their community and that sort of thing?
Yeah, I think that's tied in, and there's sort of equities in there now. I think that's becoming more and more prominent. But yeah, so this idea of, is it safe, to go outside your door, even to walk in the neighborhood, and that could be crime related stuff, or it could be some environmental exposures. If you're living next to a brown site or something, you don't necessarily want your kids playing in that empty lot, right? So I don't think, I know there's been a little bit of work on that. Not a ton though.
We're really just seeing the term come up. And I work for a small consulting firm in Cambridge. We do a lot of different things, but a lot of the principals are working a lot on environmental justice right now. And we're really just starting to see the term come up a lot in research and in things that the clients are bringing to us.
Yeah. So I think that the whole the issue of equity and systemic racism and how that sort of
it often boils down to, is it safe to go outside for an extended period of time and do things like bring your heart rate up and bring your respiratory rate up?
Right. If you're going to be, exposing yourself to some other,
next to some ponds.
Yes. Yeah.
One last one.
Yeah, you mentioned that it was kind of difficult to execute kind of the large NIH studies when it's hard to get kind of good data and see the effects of them. Could you kind of expand on that a little bit?
I think I was talking about the interventions.
The interventions.
Yeah, so when we do our physical activity interventions, not all, but most have sort of modest effects. So if we're looking at, a 5-year NIH study, several $1 million, you're doing 2 or 3 years of that time as your actual intervention. You might see an increase of 5 to maybe 10 minutes of moderate to vigorous physical activity per day. It's not huge when we look at and that's using our accelerometers to measure that. So on a population level, if you expand that out, if we could do that on a population level, then that's a big effect. But in that one study, it's probably we moved the needle, but we're not like where we want everybody to be. And I think one of the challenges there is that we look back at that social ecological model. A lot of our interventions, like even if you get a $5 million grant from the NIH, like trying to fix everything in that social ecological model it's not going to happen, right? Just building a 1 mile sidewalk is probably $5 million these days. So just trying to, I think we have to be realistic with what we can expect there. But so a lot of the interventions that we do are sort of modest to even no measurable effect. And I think it's just because we have so many of these external factors that we can't control and we don't know about. So.
Thank you so much.
All right.